Algebra II 7.7a, Imaginary Numbers and I. Okay, we're up to 18 previous videos for Chapter 7. And if you get lost during this video, my advice is to go back and watch the previous videos, and there's links to them in this video's description. In the set of real numbers, negative numbers don't have square roots. An equation like x squared equals -1 has no solution. Imaginary numbers were invented so negative numbers would have square roots and certain equations would have solutions. These numbers were developed using an imaginary unit named I, and the agreement that I squared equals a -1, or I equals the square root of -1. We need a number multiplied to itself to solve this. So if we have the square root of -25, 5 times 5 doesn't equal -25, so that doesn't work. -5 times -5 makes a positive 25, so no, that doesn't work either. If we have -1, the square root of -1, if we try 1 times 1, well, that doesn't work. That gives us a positive 1. And if we multiply a -1 to a -1, that gives us a positive 1, so that doesn't work either. So, because we have to have a number multiplied to itself, it doesn't work. So here's the definition of imaginary numbers. The imaginary numbers consist of all numbers a times I, where a is a real number and I is the imaginary unit with the property that I squared equals a -1. And the square roots of all negative numbers can be written as a product of I and a real number. We factor a negative radicand in terms of I by using -1 equals I squared. We treat that I as if we're assuming it's a real number. So now we can do the square root of -25. We factor it as -1 times 25 as the radicand. We can give them their own radical sign and say it's a square root of -1 times the square root of 25. And knowing this up here, we can say that I squared as the radicand, the square root of I squared times the square root of 25. See? Because these are the same. So this square root of -1 is saying the same thing as the square root of I squared. And there's a little invisible 2 root here, isn't there? When we don't see a root. So because that's to the second power and we have a root of 2, we can remove that radical sign and just have an I times 5, right? Because the square root of 25 is 5. And we write it where the I is behind the 5. So we say 5I. Now, some mathematicians call I a lateral number instead of an imaginary number. Just so you know, if you hear someone say that, you've heard of it, okay? All right, so this is the biggie about imaginary numbers. The first 4 powers of I establish an important pattern and should be memorized. If you can't memorize them, at least write them in the inside of your notebook so you can find them really quick, because you're going to end up using these, okay? But they're not that hard to memorize if you look at what's going on here. We have I to the first power, I to the second power, I to the third power, and I to the fourth power. Okay, so they're all in order, exponentially. But if you look at what they equal, this equals an I, this is a -1, that's a negative I, and that's a 1. If you look at the ends, they're both positives, aren't they? We have a positive I and a positive 1. And the middle ones, the 2 and 3 exponents, are negatives. But this I is not next to that negative I, and that -1 is not next to that positive 1. It's skipping, isn't it? So we're going to go I, then the -1, then the negative I, and then 1. I, -1, negative I, 1. All right? Maybe you can think of some little song or some rhyme to help you remember that, okay? But for me, the easiest way to remember it is that the negatives are in between here, but the I is not next to the I. See? The negative I isn't next to the positive I. All right? So the only way you can have negatives in the middle here is if that was the -1. Okay? So here's what's happening. We have I to the first power. Well, that's just like any number to the first power. If you have 5 to the first power, we have 5, right? So if we have I to the first power, we have I. We have I to the second power. Well, I keep telling you it's equal to a -1, but what's happening is we've got the square root of -1 squared, and we can take off that radical sign because it's squared, and we just get the -1. this I to the third power is the same thing as I squared times I, right? Because that's to the first power. So that means we're multiplying this I times a -1. And anytime you multiply a number to -1, you get that negative number, don't you? So we have a negative I. For I to the fourth, we can do either I to the third power times I, or we could do I squared times I squared. We're going to get the same answer. If we do I squared times I squared, well, I squared is a -1. So that means we're doing -1 times -1, which gives us a +1. So there's our pattern. I, -1, negative I, 1. See? I, -1, negative I, 1. I, -1, negative I, 1. See? And we can express numbers in terms of I. Just remember that I squared equals a -1. If we have the square root of -5, we can factor it as -1 times 5 as the radicand. We can split them into their own radical sign. So we have the square root of -1 times the square root of 5. We know that -1 equals I squared, doesn't it? So that means we have the square root of I squared times 5, square root of 5. And because this is squared and we have a root of 2, we can remove that radical sign and we just get I times the square root of 5. See? We just turned that I squared into a -1 and vice versa, see? If we have the negative square root of -7, well, then we've got the negative square root of a -1 times a 7 when we factor it. If they each had their own radical sign, it would be the negative square root of -1 times the square root of 7. Well, we know that that means I squared, right? So if we remove the radical sign and the little exponent, we would just have an I. But we've got this negative here, so we have a negative I times the square root of 7. Square root of -99 can be factored into a -1 times a 9 times an 11 as the radicand. If we split them into their own radical signs, we get the square root of -1 times the square root of 9 times the square root of 11. We know that 9 is a 3, isn't it? And we know that's going to turn into just an I when we remove the radical sign and the little 2 exponent from the I, right? So now we have I times 3 times the square root of 11, and we write it with the 3 in front of the I, so it's going to equal 3I square root of 11. Okay? Now, I'm not done teaching you about I. You can watch the next video to understand more about I, and we're going to talk about simplifying the powers of I and the patterns that they make. So there's actually a pattern. Did you know that any multiple of 4 is going to equal a +1? And I'll show you that in the next video. I'm going to add this video to the Algebra 2 playlist to help you study. There are no Algebra 1 videos on this topic because it's not covered in Algebra 1 for imaginary numbers. And all the videos that can help you if you're confused, there were 18 previous videos that talked about factoring radicals, it talked about the roots, it talked about all of that. So if you're lost right now, it's because you're skipping some steps. And when you skip steps, it's harder to climb, okay? If you want to have an easier time climbing a ladder, you need to go and use every single step, okay? All right, so let's talk about the patterns that we can make with these imaginary numbers I, and how you can figure out what I to the 37th power would be. To any power, okay? I'll show you a trick and show you how. Bye.